Hello and welcome to another video. Today I will show you how not to use cross-apply or outer apply. Thank you, Brian, for your persistence. You made me make this video. I will show you how one query that I optimized, I think about 1,000 times. It was like 7 hours down to a few minutes. And this is the trick. First, cross-apply sounds fancy, sounds like when you use it, you know about T-SQL. But the truth is that cross-apply is not always good. It's similar to nested loop. Nested loop functions very well with small amount of rows. You have two branches, upper branch which drives the loop and lower branch which gives you feeds the data. But if you have a lot of iterations in nested loop is not efficient. Full scan is better. Similar is with outer apply. Outer apply is only for some situation, and I will illustrate you what situations. So let's see. On the screen we have a table of 5 million rows. Table is street, simple table, random generated ID. No. ID is like a identity, 1, 2, 3, but generated with this expression, row number. Then we have a street name, some amount, which is currently empty, and date of that amount, which is currently empty. So that is created, 5 million rows. Then we have street details. It's like a child of that parent table, and it also has street ID, which is foreign key relation, and date, amount. And the game is what we look for. It's a parent child, so we have street and street details, and in street details we have some data we want to search. We want to find the biggest amount, maximum amount for a street, and to update the parent with that maximum amount, and not just with amount, but with date of that amount. And how to do that? Let's see. Now let's see how data looks. So you see the street table, it has ID, some name. Okay, poor name, I know, but what can you do with the new ID to generate random names? Then we have these two fields we want to update, we want to fill them. And then we have this child table, and child table has, for each street, has several dates, amounts, and we want to find the biggest amount and which date it was. For example, here, maybe this is the biggest amount and this date. So we want to fetch this and update parent table with that. That's our task. So let's set statistics. Let's turn actual execution is already enabled, and let's give it a try. First, let's see the plan. How plan looks like. Well, scans, nested loops, spools, but we have parallelism, so we'll see. Subtree cost 60,000, not good, not good, but let's see how it performs. So time is here, you can see how time goes. It's still running. How long must this query run? How long? I want fast queries, not slow ones. 1 minute. How can we make this query faster? We will see soon. It's not that difficult, you will see. But first, let it finish. Let this beast finish. This is really slow query. I think on production it went like 7 hours. It was super long, super slow. It keeps waiting and waiting. Oh, it's there. Okay, only 2 minutes 46 seconds. Only, what's this? 96, almost 100 million reads. Definitely not good. Execution plan. Execution plan. Well, nested loop 5 million times from a spool. Not good. Let's see what can we do. Eliminate spool with no performance spool hint. No. That would be even slower. In fact, these performance spools give you faster results, believe it or not, often. But that means we probably didn't get the best plan, maybe lacking indexes, etc. So let's see what is the solution. Solution is without outer apply, because outer apply performs bad if you have a lot of rows in the upper branch. And let's see how it performs if we write the same thing without outer apply. So instead of taking each row of the street and looking with cross apply, give me the top amount ordered by amount descending. So give me the maximum amount, row with the maximum amount, and his date. That's what this is doing. Give me the row with maximum amount and his date. And some other filters like date is less than now. Same street ID as the outer table. And it finishes in nearly 3 minutes. Let's see the same thing. How can we write the same thing without outer apply? We will use winnowing function. So we go to the street details again, same filter about date, but how to find the top one amount and date? Well, we will not use outer apply or top. We will use row number. We will partition by street ID to restart numbering for each different street. So we order by amount descending and get numbers 1 to 3. 1 is for maximum amount, for highest amount, because we have descending. And then we join with that to the street by street ID. And then we select only first maximum amount, row with maximum amount. And then we take date and that maximum amount to update our table. I like this form of update, because it's similar to select. For example, this could be a select. If you would write select d.star, you would see it's a select, normal select, you can run it. But we want to run a select, we will say like this, and we will run the update. That's why I like this form. And let's see how it performs. First, let's see, execute, finished. Finished in 0 seconds. Can you believe this? 0 seconds. I mean, it's not 0, it's less than 1. But how much? Let's see, it is less than half a second, 400 milliseconds. CPU time is bigger, but it was a parallel query, so clock time was super small. Let's see the execution plan. Still, we have scan, 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 sort, all the ugly things, but somehow without a nested loop. So this thing is much faster. And we have a missing index here, but it won't help. This missing index is not always right. And you shouldn't blindly create indexes suggested here. It's just a guidance, something to try. Is it better? And to merge it with existing indexes, not to pile up too many indexes on the table. Okay, let's see what if we can create indexes. These are heaps, so no wonder we have such, you may say, no wonder because we don't have indexes. Let's create indexes. So this is a natural index by street ID. But for this table, street details, this is not so natural index. And you might not have luxury to create such an index, especially clustered index. That means it has all other columns there, street ID and the month. So this, in practice, in production, you probably won't have luxury to create this second one. First one, yes, but second one, because if you have a lot of columns, maybe it's not the best idea to create a huge index somewhere if you need this query only once or several times. Okay, let's see now how it performs. This original query, let me just run it now. Okay, let's see. Oh, 11 seconds, very good, very good. Logical reads, is it 15 million, 16 millions? Not bad, not bad, 11 seconds. And our lower query, still 0 seconds or half second. You see, you don't need to have ideal indexes to make this query fast. In fact, ideal indexes may not help at all. And still, this query is 20 times faster than this other query. That means you can achieve much better performance without cross-apply, without auto-apply. It all depends on amount of data, what is the situation, and if you look at this execution plan, you will see something interesting. This plan starts with street details. When you use cross-apply or auto-apply, you basically lock the optimizer to use in that order, to join tables in that order you wrote them. So upper thing becomes upper branch, lower thing becomes lower branch. You didn't give the freedom to optimizer to actually optimize the query. Now with this plain join, we gave optimizer freedom, so optimizer can choose a better plan and start maybe with this lower branch first and then with this second table. And that's why also we gain speed here. And let's look at this first execution plan. If you see, it became serial plan after we created index. And what is the conclusion? Conclusion is cross-apply and auto-apply are not silver bullet. You cannot use it everywhere. It all depends on number of rows. If you have a lot of rows in upper branch in a data set before cross-apply, you will probably get poor performance. It's case-by-case basis, but it's really risky on big number of iterations. Similar to nested loop. And don't use it blindly, don't write it. I saw even some frameworks like entity frameworks do it by default. Totally ignorant of number of rows, they do that cross-apply, baking the plan into system, and that often performs really bad. It's a bad practice, don't do that. I mean, there are much better methods, as you saw, much better. So this query was super fast after this optimization without creating any new indexes. And it was really great. And that's why one really brilliant guy made me do this video. So if you like this video, please press thumbs up. If you don't like it, press thumbs down. And this is my contact. And see you again in the next video. Bye bye. If you like this video, please press thumbs up. If you like this video, please